Hi, this is Solid Waste Energy by Team Pepto. So here's a brief overview into solid waste energy recovery. So the majority of municipal solid waste is landfill and left to degrade. So this is 53% out of the total 258 million tons of waste generated every year. And so the combustion with energy recovery is only 13% of this energy. And so since population is always growing, represents a big issue because as the majority of waste is left to landfill, there's going to be a lack of space and an overwhelming amount of contamination pollution coming from these landfills. And so energy recovery from this waste is an opportunity to decrease the amount of landfill space that we need and allow for repurposing of this waste. So storing waste in landfills take up space and is a source of contamination such as groundwater and runoff. And the energy in this solid waste can be harvested through combustion. However, this is only done for 13% of this waste. And plasma gasification is another method of energy generation from waste, but it's usually only used in smaller islands and it's just rarely used because it's expensive to build. And so there's also another method of energy generation from waste, and that is using decomposing waste, which generates methane, and the methane can be harvested from this waste in landfills, and then that can be used as energy. Yeah.
So I'm going to be talking about the combustion aspect of energy from solid waste, and MSW is municipal solid waste. So first, MSW is unloaded from collection trucks and placed in a trash storage bunker. Then an overhead crane sorts the waste, and it's lifted into the combustion chamber to be burned. After it's burned, the heat released from the burning converts water to steam, and the steam rises and is sent to a turbine generator to produce electricity. And yeah. The other aspect of solid waste energy that we'll be demonstrating is methane release after biodegradation. So this is our model.
So right here on the your left, you have what we would consider a well-managed landfill, and that uses organic material and a liner to allow the organic material, which is here represented by this green styrofoam, to biodegrade and decompose. Now this is an artificial material, and this is unlikely to decompose, and this will not create methane. Now here, this is a representation of a slightly mismanaged landfill that uses sand, and this is less likely to show effects of decomposition.
2 weeks later.
All right, welcome back. It's 2 weeks later. Let's see how our things have done. Now this is our stand-in for the apple, the green styrofoam. And as you can see, in the well-managed with the organic soil, the organic representation with the green styrofoam has really decomposed. It's falling apart. But if we look over here, the inorganic material has not really shown any biodegradation. Obviously, if this was left in here for many, many years, it probably would show some signs, but as of right now, there are no signs. If we looked in the mismanaged landfill, we'll see that the green styrofoam has slightly decomposed, but nowhere to the same effect as the one in the organic landfill. Additionally, as you could probably guess, the inorganic material is not decomposed at all. And what this is modeling that the organic material, when it decomposes, it'll release methane. And the problem is, if this green styrofoam had been covered with many layers, this methane would build up in the soil So this methane would build up in methane deposits, and we need to deal with it. So that comes in, once we deal with it, we can actually harness the methane, but we'll come to that in the next slide. So methane from solid waste. So in a landfill gas, or LFG, is produced as a byproduct of organic materials decomposing. Now, this LFG is composed of 50% methane and 50% carbon dioxide. So municipal solid waste accounts for about 15.4% of methane waste in the nation. So in order to capture this LFG, there's lots of different methods of piping, but it's usually pretty easy to capture. Then the methane is then treated in a process that I'll be shown in the next slide to create electricity.
So the first part of treatment that it goes through is primary treatment, which is essentially just moisture removal. Then it goes through secondary treatment, which is impurity removal, such as siloxane and sulfur if needed. And then it goes through advanced treatment, which removes CO2, nitrogen, oxygen, and VOC removal if necessary.
So in this diagram, it's an overall representation of the entire process from collection, processing to methane uses. And as you can see, the methane that is brought up from the landfills can be used in lots of different things, from vehicle fuels to electricity to pipeline gas. So as people have realized the use of methane, the methane production has drastically increased just since the 1970s. However, despite this increase, the actual amount of emissions are falling, as seen in the second graph, and this is due to an increase in technological advances.
Methane, which is a natural gas, is much more efficient than things like coal and petroleum because it doesn't contain impurities like sulfur dioxide and therefore is much cleaner. For example, natural gases only have like 10% waste and 90% of the energy is delivered to customers, while coal or petroleum have 27% delivered to customers and 73% waste.
So here is a graph of the U.S. municipal waste generation since 1960 up to 2014. And we can see that the waste generation in the U.S. has grown a lot since the 1960s, and that it is slowly growing ever since like the 2000s, even though it may be like plateauing out. And this is a problem since as waste generation grows, the need for landfills and more space to build these landfills becomes a problem. So here are some pros and cons of solid waste energy. A major pro is that the use of solid waste energy reduces landfill waste, which is essentially obtained by burning the waste so that it takes up less space. And it also produces electrical energy. And not only that, but it reduces the distance that the waste needs to travel to the landfills. And it also it has a lower water pollution risk compared to a landfill, which has a chance for runoff and groundwater contamination. And in general, this reduces the need for landfills as we repurpose the waste to become electrical energy to be used by consumers. So here are some cons of solid waste energy. So once the waste is burned through combustion, ash is a byproduct, and also it emits air pollutants and greenhouse gases. And not only that, but it's expensive to build combustion plants or gasification plants, and poses a health risk to local citizens. However, if we think about it, most of these cons are due to the location of these plants. So if we're able to build these in a more remote location from citizens, it reduces the chance for health risks for local citizens, and also takes away the effects of these air pollutant greenhouse gases on the city area or the population density. In conclusion, solid waste energy has a lot of potential, and there's multiple avenues to create energy from solid waste. And solid waste energy represents a renewable energy source that can be used to reduce the need for landfills, especially because waste has become a growing problem as the population grows. And so by using solid waste energy, we allow an option to reduce this waste and then provide electrical energy to fuel this growing population. Thank you for listening.